time we learned about mean, median, and mode, and those are all measures of central tendency. So that means the center of the data. We talked about outliers, how they can affect the measures of central tendency and kind of make your data seem a little skewed. We also talked about percentiles, and remember, percentile means if Joe scored and was within the 90th percentile on the last test, 90% of you people scored below him, right? Everybody. So that's what that means, percentile, at or below that. So that's what we learned last time. We learned about how to make a box and whisker plot and whatnot. All right, so today we're going to be talking about standard deviation. So standard deviation is a measure of how far the numbers in a data set deviate away from the mean. Now remember, mean means average. So if we have the average, of a data set, we can look and see how far the data falls within the mean. So that means the further away from it is from the mean, the more standard deviations it's going to be out. So if it's closer to the average, it's closer in standard deviation. You'll either be given the standard deviation and the mean, or else you can use your calculator to find that. So it's talking about what standard deviation, guys, does is it takes the average. So let's say that this is my average, and it will tell you how spread out the data is. So this would be 1 standard deviation away from the mean, 2 standard deviations away from the mean, 3 standard deviations away from the mean. So does everybody see what I'm kind of talking about here? It's talking about the spread of the data. Okay, variance, I'm going to be honest with you, literally, I'm not a statistician. Like, I took 2 stats class in all of my 25 million math classes, and they were like beginning level stats pretty much. So I don't even know what variance is used for. Like, if I was a statistician, I'd be able to tell you, and if you go into statistics and whatnot, but they'll ask you to find the variance, and if they do, you just have to know how to find it. We don't even use it though. We do use standard deviation, but in this class, we won't even use variance. But standard deviation is written as sigma. So, and that's just going to be like, you'll see in our calculator in a second, when I show you how to find it in your calculator, it'll say sigma. Does that make sense? So that's just how they write standard deviation as sigma. And then just like, remember with mean, they write it as x bar. Sigma is how they write standard deviation. So to find the variance, you'll literally square your standard deviation. You'll take your calculator, whatever, 2.5 squared, and that's how you find your variance. I don't know how you use variance, and we won't be using it, but I'll ask you. So if we needed to, if you were in a statistics class, they would literally make you, and I literally remember in my first statistics class before I took calculus-based statistics, we were doing this by hand instead of using the calculator. So you would use this formula here, which it's easier than it looks, because we know how to find the sum, right? Sum means add them up. And then you take your x values minus the mean, you square that divided by n, and then you square root it. That would find your standard deviation. So in a statistics class, you will be asked in college to do this by hand, which is not hard, it's just kind of tedious. We're just going to use our calculator, but this is how you do it if you're interested. So like, given these values here, guys, these are our x values. We could find the mean by adding them up and dividing by 1, 2, 3, 4, 5. There's our average. Boom, 7.4. Does everybody see? So then what we would do is we would take all of our x values minus the mean. So x minus x bar. So that minus that, that minus that, that minus that, that minus that, that minus that is that. Then we would square them next. So you see how they squared those values? And then they would sum them up, add them up. And then they would divide it by, let's see, what was in the formula next? They would divide that sum by, by 5, and then they would square root it. So that's how you could do it by hand. I'm not going to make you do it by hand. This is not a stats class. So let's just use our calculator right now. Here we go. It says find the mean, variance, and standard deviation. Let's just use our calculator. Let's not do it by hand. So pull up your calculator and go to list 1. And type in those values. So remember that in your calculator, you hit the stat key and then into edit. Yeah. Come grab one real quick. So stat key and then edit. And then in list 1, type in those values. Now remember, if you want to clear out the list, don't hit delete, hit clear, scroll down. I'm good to go. So type in 52, 63, 65, 77, and 80, and 82. And I'm going to have you read those back to me while I type them into mine. Okay, so you said, oh my heck, my computer's having issues. Okay, so what was the values? Thanks. Okay, thanks. Now hit the stat key again. Same thing, over to one variable, over to calculate, down to one variable statistics, hit enter. Hit enter again. Now remember, if your calculator is a little bit more advanced, you just enter through all that weird stuff. And now look, here's our X bar. So our mean is 69.8. Our average is 69.8. And then look, it tells us what the sum is, the sum squared. Well, cool, we don't care. But we do care about this. This is the standard deviation, and this is also the standard deviation. They're just different standard deviations. One's based on like the population, and one's based on the data set you entered. So we're just going to all agree to use the bottom one, sigma. So our standard deviation is 10.7. So you'd say X bar, which is the mean, this is how you answer this one, X bar, our mean is, what was it, 69 point? And then our standard deviation was, I just said it, I said 10.7. And then our variance would be that squared. So now you'll have to do that one by hand. Type in 10.7 squared for me. Perfect. So we won't use that for anything. We would use this for something and this for something, but I'll show you how you'd use it now. So what this will allow us to do is say, given the average, how is this spread out? How many standard deviations is it away from the mean? Now, sorry. The closer it is, the lower the number of standard deviations that all of the data will fit, the closer the data is. It's less spread out. The less the amount, the spread, the better the data is to be used. So if it's way spread out, it's kind of not the best to use to make general conclusions and whatnot. Okay, so this would be what you'd be asked on a test. So it said, within how many standard deviations does all of the data fall within the mean? So for example, in a data list, every value falls within some number of standard deviations from the mean. For example, if the mean is 50 and the standard deviation is 10, then the values within 40 and 60 is within one standard deviation from the mean. So let me just show you that written out. So if 50 is our mean, I'm going to put a star by it. Then if we go one standard deviation above and our standard deviation is 10, that would be 60. If we go one standard deviation below, we would subtract 10, we would be 40. Does everybody understand? So any value that falls within 50 to 60 would be within one standard deviation of the mean. That means it's very close to the average. So is 55 within one standard deviation of the mean? Yes. How about 42? Yes. Okay. So if we were to go two standard deviations out, that would be 70. So values between 60 and 70 would be within two standard deviations of the mean. So 65, for example, 60 is in 1, 61 then is in 2. Does everybody see how this works? Okay, and so on back this way. So this would be 30. So the further out we have to go, the standard deviations, the more spread out our data is and the less reliable it becomes. So looking at this example here, grab your calculator so we can go quick. It says the mean length of Beethoven's 9 symphonies is 37 minutes. Its standard deviation is 12 minutes. Within how many standard deviations do all of these fall? So let's draw out our picture here. So 37 is our mean, right? Then I'm going to put a star by it because I want to know that's my mean. One standard deviation above would be adding 12. What does that put me at? Adding 12 would be 49, wouldn't it? Okay. And then subtracting 12. Everybody tell me real quick. 37 minus 12. All right, perfect. Let's do two standard deviations now. So 49 plus 12. And then let's go two standard deviations below. So 25 minus 12. Perfect. Now, we could keep going. Let's see if that entraps everything. In fact, it doesn't. So, for example, let's see, where does 27 fall? Within how many standard deviations? So right here we have 1, right? That one was within one standard deviation. 30 fell right here, correct? Cool. How about 47 in here? So all of these so far have fallen within one standard deviation. They're all close to the average. 35 is also in here, isn't it? And then 30 is also in here. We already did that. 40 is right here. 35 is right there. 22 is down here. Okay, now we're getting further out, 2 standard deviations from the mean. And then now let's do 65. Oh, crapola. It doesn't fit. We better go out one more standard deviation. Does everybody see how I have to go out one more? So then this plus 12 would be 73, right? So then my 65 fell within 3 standard deviations. So this is kind of spread out. In fact, we know this is considered an outlier, correct? Because I remember how I told you if it falls further out than 2 standard deviations, it is then considered an outlier. So anyways, fun fact for you. So we have one outlier anyway, so it's spread out a little bit because of the outlier. So we would say 3 standard deviations. All of our data fell within 3 standard deviations from the mean. Because it took 3 to get out there to all of it. Does that make sense? Even though it was only 2 below, it took 3 to entrap all the data. Yes. Yeah. Yep.
And then do they always give us a standard deviation?
They will, and if not, what we could have done here was taken these values, typed them into our calculator, and got the mean and standard deviation that way. But most of the time they'll tell you, just as easy as that. Literally nothing harder than that. Good questions. Okay, so we don't need to do another example like that, right? You're all good, you get how it works. Draw out your picture like I drew out and kind of see where it falls. So they might say, this might be a valid question on a test. Within how many standard deviations does 40 minutes fall within the mean? 1. So that's as far as it's going to go. So pretty easy stuff. Okay, finish 12-2, and then we'll move on to 12-3, also a very easy lesson. So let's go ahead and finish 12-2. Ready, set, go.